Hello students, in today's video we're going to learn the basic concepts of how we can apply the angle of elevations and angle of depression to solve some trigo problems. Right, I'm going to use a very simple story to explain how what this angle of elevations and the angle of depressions is all about. So supposing one day you're walking along the street and then you saw a very unique looking bird perched on top of a tree. And quite obviously, this is a very unique bird because I don't think you ever see that in your real life. Okay, and that is you. All right. And then so what happened? So you see this bird, of course, you look at it, right? So you will kind of look up. And when you look up, your eyesight will actually form a right angle triangle. Okay, so you see that we're only concentrating at the angle from the eyesight. We disregard the height of the person, the height of you, right? Because when we are solving questions for simplicity, all right, we disregard the height of the persons. Okay, so the angle of elevation is just the angle that mixed with when you look up, and then the angle of elevation is just the angle made with the horizontal level, okay, the horizontal axis, right? So that's angle of elevation, right? And of course the birds also see you walking. You also caught the attention of the bird, and the bird looks down at you. So when the bird looks down at you, right, you will see that it will form a angle of depressions, okay, with the horizontal axis. Okay, and if you were to look at the diagram again, you will see that both the horizontal axis when the bird on top and the horizontal axis at the bottom actually parallels, and therefore we can actually apply alternate angles, right? And therefore the angle of depression is actually equals to angle of elevations based on this alternate angles property. All right, so the very important to take note is this angle of elevations of angle of depression is the angle that makes with the horizontal axis, okay, with the horizontal axis, right? Right, let's look at this questions. Supposing you have office tower, which is 43-meter high, and then the angle of elevations, it's 34 degrees from a point on level ground. All right, so you have to imagine that you are actually standing at the point on level ground and looking up at the top of the office tower. And you ask to find the distance of the point on the ground from the foot of the tower. All right. Okay, so we have an office tower there, and then we have a point, a level ground, yes, and then the point there, and the angle of elevations. Remember, the angle of elevations is the angle that when you look up. So you have to imagine that you are actually standing somewhere here, okay, and you look up to the top of the tower, and that therefore the angle of elevations, yeah, so that will be 34 there, and the tower is 43-meter. Okay, so you actually stationed here at that point there, and you ask to find the horizontal distance, the one that's highlighted in blue. Okay, so since we're talking about the right angle triangle, what are the concepts that we can use involving right angle triangle? Yes, we can use Pythagoras theorem if you're finding the length. Otherwise, then we can apply Torcaso. Remember, Torcaso is only applicable to a right angle triangle and not any other triangles. Okay, a right angle triangle. So therefore, we have to label the three sides properly. So the sides that it's opposite the 90 degrees, the one that's opposite 90 degrees is always the longer side. So that will be your hypo. Okay, the sides that is opposite the angle, this will be your opposite. And of course, we have the level ground, which is the adjacent. Okay, so the next thing is to just write down Torcaso. Right, so we will just tick on the values that we're given. So supposing we're given the opposite side, so we just put the tick on O, and then we need to find the level ground, the one highlighted in blue. So we need to find the adjacent distance. So we need to find A. So therefore, you see that from this Tokaso, right, the one with the 2 ticks will be the one that we will be using to find. So in this case here, we need to use the trigo ratio for tangent. So therefore, tangent 34 degrees is equals to opposite sides, which is 43, divided by the adjacent side, which I call it the distance. All right, and then we just do a cross multiply. Yeah, and from there, just do a cross multiply and then divide both sides by tangent 34, and you'll get the distance, the one that's highlighted in blue, to be 63.8 meter. So what this question is saying is that if you stand at 63.8 meter away from the foot of the tower and you look up at the top of the tower, for whatever reasons, I don't know, the angle of elevation is 34 degrees. Okay, that's how you solve it. Right, this question is involving a girl, Li Ting, flying a kite, right? And the kite, it's the string of length that's 100. The kite is attached. The kite is attached to a string. Total length is 140 meter. Okay, and then the angle of elevations of the kite from her hand is 58 degrees. So assuming that the string is taut, assuming that is the strong wind blowing, and then the string is taut, right? So determine the vertical distance between her hand and the kite. So I'm going to use an image, okay, to explain, because a picture tells 1,000 words. So we have a girl Li Ting, right? And then she's flying a kite, right? And yes, that is a kite. It's not an octopus. There's a kite. All right. So the string is taut at 140 meter, right? So you make a right angle triangle. Okay. The angle of elevations of the kite from a hand is 58 degrees. So 58, that will be a 58 degrees. Okay. Right angle triangle, Tokaso. So that's label all the relevant sides. Oh yes, I was supposed to find the one highlighted in yellow. Okay, because you're supposed to determine the vertical distance between her hand and the kite. So that is the one that's highlighted in yellow, which I'm going to call it X. So let's label all the appropriate sides. The one opposite 90 degrees will be hypo, the one opposite your angle will be opposites, and of course the remaining one is the adjacent side. Similarly, write down your Tokaso, and similarly, take on, you see that we have to use the trigo ratio for sine, because we need to find the opposite side. So O is the one that I need to find, and we're given the hypo to be 140 meter. So you see that under Tokaso, so is the one with 2 ticks. So we use the trigo ratio for sine. So therefore sine 58 is equals to x over 140, opposite over hypo. Again, we do a cross multiply, shortcut. So x will just be x times 1 give you x, right? Will just be 140 times 58 degrees. And you have to round it up to trace significant figure. So that is 119 meter. Right, let's proceed now to question 3. So for question 3, we okay, it's slightly different because the first 2 questions we actually managed the concepts on angle of elevation. So for question 3, we're talking about angle of depression, and this is quite interesting question because we're talking about Singapore Flyer, right? And then imagine you are in the cable car and then you go up to the highest point. Imagine you are this girl called Cheryl at the highest point, and then you look down and guess what? You see a sports car there. Okay, and then we need to find the angle of depression. Okay, so same thing, I use a picture to explain what's going on. Okay, so that is your Singapore Flyer. Okay, right, and all the cable cars there. Okay, and then yes, we have a sports car, right? Unique looking sports car again. Okay, and you are Cheryl, you are at the top, you are at the highest point, right? And then you look down. Yes, you are at point A. Okay, you are at the highest point, which is point A, and you look down at the sports car. So the angle of depression is the angle that makes with the horizontal axis. All right, 25 degrees there. Okay, you look down. All right, and we're given the height. Okay, the height of your Singapore Flyer from the top. Which part of it? here. This piece of information here. Okay, the highest point of the wheel is 165 meters above the ground. The highest point of the wheel is point A. It's where Cheryl is. Okay, so from that point to the ground, the one highlighted in yellow, that one is 165 meters. Okay, then let's see what happened. Right, so you asked for part I. Part I, you asked to find the distance of the sports car from the point B. So point B is directly below point A. So that your point B is this point here. That is your point B. Point B is directly below point A. So you ask to find the distance that's highlighted in blue. Okay, so we're talking about right angle triangle again. And remember we said that the angle of depression is equal to angle of elevations because you see the two parallel lines there. You can use alternate angle. Yes, right. So same thing, if we're using applying Tokaso, we have to label all the appropriate sides, opposite sides, adjacent, hypo. So the one that's opposite your 90 degrees will be your hypo. The one that's opposite your 25 degrees will be your opposite sides. And of course, the adjacent is the one that we need to find. Okay, so we use tangent because we need to find A and we know O. So we use the trigo ratio for tangent. So tangent 25 is equals to 165 over x. So we just do a cross multiply, okay, and then divide by tangent 25 on both sides, and you will get the distance. That means the sports car is 354 meters from point B. Point B is directly below point A. Okay, so that's part I, relatively easy. Okay, so part 2 is a little bit challenging. Part 2, what happened is that right now we have to find the angle of depression, but the angle of depression we're not going to find from point A. We know point A, the angle of depression from point A we were given is 25 degrees, right? But what do you think will be the angle of depression from the center of the wheel? I'm not too sure why would someone go to the center of wheel, right? But let's see what happened. The angle of depression from the center of wheel, do you think would that be bigger than point A or would be smaller? Okay, let's see what happened. So back to our Ferris wheel, back to our Singapore Flyer, back to our sports car. Okay, right. So in this case here, the triangle will be slightly different. Okay, the triangle will be, yes, that will be the triangle. Okay, the angle of depressions will be taken from point W, which is the center of the wheel. All right, so we have already found the distance of the sports car from point B earlier on. Remember in part I, sorry, which found out to be 343.84. Okay, here you see that I do not use 354. Okay, you do not use 354. Otherwise, your answer will not be exact in the end. Okay, for your answers to be more accurate, not exact, sorry. For your answer to be more accurate at the end, you have to use 353.84. At least 5 significant or 2 decimal places. Okay, for in between answer, so that your final answer will be more accurate. Because your final answer is 3 significant figure, or if it's an angle, is 1 decimal place. Okay, right. So what we need to do is, what is the angle that I need to find? So, all right, okay, before we actually show the angle that we need to find this length here, from here to here. We need to find how much is that. Okay, so we know that the distance from point A to B is 165, right? The distance from point A to B is 165. Right, and the diameters of the ferry wheels is 150 meters. Diameter is the one that highlighted in pink. Okay, diameter is highlighted in pink. So radius will be 75, right? That means the radius is 75. So the one that highlighted in blue will be 165 minus away 75. Okay, let me repeat in case you are confused and don't know what's going on. The height, okay, that point A, okay, if we were to remember, point A to point B is 165, right? And the diameter of the Ferris is 150, so therefore the radius will be just half of 150, which is 150 divided by 2, right? So therefore the one that highlighted in yellow will just be 165 minus 150 divided by 2. That gives you 90 meter. Okay, all right. So the angle of depression is the one you look down, which is actually also equals to the angle of your elevations, right? Okay, and in this case here, right, you know the opposite side. The opposite side is the one that highlighted in yellow. That is your opposite sides. The one highlighted in yellow is your opposite sides, OPP. The one highlighted in blue is your ADJ. Therefore, you use tangent ratio, okay, because you need to find O and you have A. So therefore, we use tangent ratio. So tangent alpha will be 90 meter over adjacent side, which is 353.84. And then you tangent inverse the value. And for final answer for angle in degrees is one decimal place. So 14.3. Oh, so 14.3, it's what happened? Smaller than the 25. Okay. So when you are looking down at the cow, that means you're nearer because the height is shorter, right? Yeah. So the angle of depression will be smaller. When you're higher up, the angle of depression will be more because you need to look down more, right? Okay. Right, so this is the time for you to try to do some questions on your own. Now this concept, angle of elevations and depressions, rather easy concepts. Okay, so you should be able to do these questions on your own. All right, so on a certain day, a 3PQ 44 meter. So you have a 3PQ 44 meter, cast an 84 meter long shadow RQ. Right, P is here. Okay, and you ask to find the angle of elevations of P from the point R. So which is the angle you're supposed to find? Yes. Oh, okay. Sorry, I did label that. So that's the angle of elevations you need to find. Okay, so try to do it on your own, and the answers you should get is 27.6. I am very sure you should be able to do it on your own. Right, let's do another questions. In this case here, it's where we need to find the angle of depressions. So remember, the angle of depressions is the angle that when you look down, and the angle that made with the horizontal axis when you look down. Okay, so we have a castle, and this castle is 280 meter high, and then a bird stands on the level ground 85 meter away from the foot of the castle. Okay, the same unique looking bird that I've shown in the earlier slide. Okay, so we can form a right angle triangle, right? So where is our 218? Oh, our 85 meter first. Okay, and then we have the one that highlighted in blue. It's the height of your tower, the castle, sorry, which is 218 meter. And you're supposed to find the angle of depression. Okay, so the angle of depressions we all know is equals to angle of elevations. Okay, right. So this is also your alpha. Okay, and you can use Stochastic. Okay, and here, which trigo ratio do we use? Do we use tangent, sine, or cosine? Right, think about it. And the answer you should get is 68.7. Right, so let's look at the last question. This one is slightly more challenging than the earliest one because this one involves having to find three distances, MA, MB, and then finally AB. Right, so given the angle of elevations from the top of the clock tower from 2 points, you'll see that the points that's nearer to the tower, right, it's bigger because you have to look up more. When you're further away from the tower, you don't really have to look up that much. That's why the angle of elevation is 37 when you're further away, and the angle of elevation it's bigger, okay, when you're nearer. Okay, so this one should not be difficult. You just have to apply Stochastic to find the length MB and then find the length MA, and then you just take MB minus MA to find the distance of AB. Okay, and you should get 9.74 meter. So please try it